Welcome to the video on integration. Integration is a reverse process of differentiation. This can be shown by differentiating x squared, which just goes to 2x. And then by definition, if it's the reverse process, then 2x should integrate to x squared. Now that, in words, if we take 2x, is raising the initial power by 1. So x to the 1 raised by 1 is x squared. And then dividing by the new power. So 2x squared over 2 becomes x squared, which agrees with our previous result. However, if we differentiate x squared plus 1, this also goes to 2x. But 2x obviously doesn't integrate to x squared plus 1. So how can we explain this? Well, we need to use an arbitrary constant, which is denoted as c. So when we do integrate 2x, we show integration normally by this sign here. When we do integrate 2x, with respect to x, we write x squared, but then we also say plus c. And what this means is that we've accounted for the potential of an arbitrary constant. And then we can also say that x squared plus c always differentiates to 2x. So that explains that little discrepancy. And what we've just covered there are indefinite integrals, where there are no limits on the integral itself. If you do have limits, say 3 and 1 with 2x, our previous example, then you just integrate normally, x squared, but then you enclose it in these square brackets, and you write your limits out as they appear on the integral side. And what this notation is equivalent to is substituting in the top limit, that would be 3 squared, and then taking away the bottom limit, which is just 1 squared. And that simplifies to 8. So we can integrate single terms in x. How do we integrate polynomials? Well, it's done in a very similar manner to how you differentiate polynomials. So we can take a polynomial of 3x squared plus 2x minus 5, and that would just be equal to x cubed plus x squared minus 5x. So we can now integrate single terms as well as basic polynomials. However, what if we came across an integral that looked like this? Now we can't simplify these two separate functions into one term, so we have to treat them separately. And what we have here is a product of two functions. So the technique we need to use is called integration by parts, and this requires a formula that looks like this. So this corresponds to this part of the equation here. And we need to allocate x squared and ln x to a value either u or dv. And as we can see from the formula, we need to integrate dv. So the value we choose for dv should be a term that we can integrate easily. So we know that we can integrate x squared, but we can't integrate ln x using standard results. It's much more complicated. So we say that dv is equal to x squared, and therefore u is equal to ln x. And then we can see that we're going to require v and du. So I can just work them out here. V is just x cubed over 3, and du is just 1 over x. Now using this, we can just write them out corresponding to the formula to calculate this integral. So x squared ln x is equal to ln x times x cubed over 3 minus integral of x cubed over 3 times 1 over x. And that can be simplified to ln x times x cubed over 3 minus x cubed over 9. We need to insert the plus c as well. So that covers integrals of products, and we've covered integration of polynomials and integration of single terms in x. Thank you for watching.